This is section 5.5, solving systems of conic sections. Okay, so what we're doing is we're having a system, so more than one conic section, and the solution is all the times that they intersect. So there's a couple different points of intersection between a circle and a parabola. So first of all, they could be on a graph and not touch each other at all. They could touch at exactly 1 point, they could touch at 2 points, or they could even touch at 3 points. Those are all the possibilities. So sometimes you might have to do a quick sketch to look at this. Here's a chart that I think you guys have been craving. In general form, it's a line. If A equals B equals 0. Okay? So if there's no squared terms, it's a line. If A and B are the same, they are a circle. If A is B or A is 0 or B is 0, it is called a parabola. It's an ellipse if they're not equal but both the same sign. And a hyperbola is if A and B are opposites. One's positive and one's negative. Okay, so here we have a question. It says identify each conic and the maximum number of solutions the system could have. So this is 5x squared minus y squared. So I have my A is 5, my B is negative 1. Okay, those are opposite signs. So I know that this guy is a hyperbola. Okay, and that's what it says right there. Oops. Didn't mean to do that. I just meant to delete that. Okay, x squared plus 2y squared. So A is 1, B is 2. So looking back in our chart, this must be an ellipse. Okay, so a hyperbola and an ellipse, you have to think about how many different ways those can intersect. They could have an intersection of a maximum of 4 solutions. So if you think about a hyperbola and an ellipse, at most they could intersect 4 times. Okay, so we could have 4 solutions, we could have less than that. Okay, so what I'm going to do is I'm going to take equation 2 and I'm going to solve it for x squared. Now that I've solved it for x squared, I'm going to sub it into equation 1. So in equation 1, every time I see an x squared, I'm going to sub in 5 minus 2y squared. Okay, so I did that right there. A little bit of work here. I've done distributive property, I've combined like terms, and I've gotten a value for y. So now that I have y squared, I'm going to sub it back in to this equation because x squared equals 5 minus 2y squared, and I get a value of x. Okay? So now I make my solutions. I said x could equal 1, positive 1, and positive root 2. Positive 1 and negative root 2. So I could have written this in more steps. Negative 1 and positive root 2 and negative 1 and negative root 2. So I probably would have actually written this 4 times. Those are all the possible points of intersection. Okay? Let's try another question. Okay, so this one is obviously going to be a line because there's no squared terms at all. And this one, my A and my B are the same, so that's a line and a circle. So how many ways can a line and a circle intersect each other? A maximum of 2 times. Okay, looking at this, I am going to take equation number 1 and I'm going to solve it for x. I also could have solved it for y. There's more than one way to solve these. Okay, now I substitute equation 1 into equation 2. So every time I see an x, I'm going to put y minus 1. Okay, so subbing it in, doing some expanding, collecting like terms. Okay, and now I come to y squared minus y minus 6. I'm going to factor that. So I have either y equals 3 or y equals negative 2. Okay, subbing that into the equation here, I have x equals 2 or x equals negative 3. So here I say that x equals 2 when y equals 3. That's 1. And x equals negative 3 and y equals negative 2. So those are my 2 points of intersection. So you have some practice questions to try on this section. As well, you have 2 questions that are handed in for marks.